Hello everyone, this is Ria Pahuja from ETCIO and I welcome you all to the webinar, The Art of Cloud Native Application Development. When a new application is to be developed today, one of the first questions posed is whether it should be designed to take the advantage of the cloud. The default New World practice is to consider cloud native DevSecOps unless there are requirements that stipulate on-prem operations. And in this webinar, the experts shall delve deep into the design points around cloud native development, application modernization, and accompanying data transformation. And for this very topical discussion, we have with us two eminent speakers with us from the industry. Please join me in welcoming Mr. Amit Mehrotra, Head of GSI Solutions Architecture India from Amazon Internet Services, and Mr. Sri Krishna Venkateshwara, CTO, Kyndryl India. Hi, gentlemen. Thank you so much for being with us today.
Pleasure. Thank you, Ria.
Before we go ahead, just a few announcements. Dear attendees, please do drop in your questions in the Q&A box provided. We will be addressing your questions as the session progresses. We will be texting you. We will be answering your questions. Without any further ado, over to you, gentlemen. Please take it forward.
So thank you again, Ria. Welcome, Amit, and welcome to our audience. Thanks for joining. So today, Amit and I will discuss the motivations to develop applications in a cloud native fashion, the major design points that go into building such applications, and the business benefits that can accrue from cloud nativity. So at Kyndryl, we help large customers modernize their IT landscape. And so we see firsthand how application modernization can lead to business modernization. And AWS is the market leader in the public cloud space. It runs many planet scale applications. So no one more qualified than Amit to join me to brainstorm on this topic. So let me start by setting the context first. So when a new application is to be developed today, one of the first questions posed is whether it should be designed to take advantage of the cloud. Yeah, so if the application needs to scale in response to varying workloads, especially ones that oscillate heavily, and you need to operate with near zero downtimes, the default New World practice is to consider cloud native development unless there are requirements or regulations that stipulate otherwise. Now, if your application is legacy on the other hand, developed years ago or even decades ago as a monolith, yeah, you can reduce operating costs and gain value by modernizing it into cloud nativity, right? And in this case, the application's internal architecture has to be redesigned, the code has to be refactored, and the resulting application has to be rehosted on a cloud platform. But the point is that modernizing business applications is often a prerequisite to modernizing the business model itself, right? So in many cases, a modernized application can lead to new operating models that help not only survive disruption, but also compete in new ways and thrive. Now, cloud native app development is a combination of several facets. Number one is architecting and developing microservices-based software. Second is deploying the microservices on container environments on cloud, then hosting the data on cloud native databases, cloud native data lakes, then maximizing leverage of cloud PaaS services. Then there is adopting DevSecOps practices to engineer continuous delivery of releases, and finally following an agile development engineering culture, right? So we want to touch on most of these during this webinar today. So let me start with the first aspect, which is the microservices architecture. So the cloud native development landscape, it starts with application architecture that defaults to microservices, right? So the microservices philosophy, it calls for decoupling application componentry into multiple independently deployable services. Yeah, so the application is decomposed into modules that perform specific micro functions. So they are rendered into interaction friendly services exposed via standard programming interfaces. There is a now popular methodology known as the 12-factor app that lays down best practices for building microservices based applications. And the microservices themselves are deployed on container environments. Yeah, the open source Kubernetes platform is the de facto standard for container orchestration. So when deployed on Kubernetes pods, container pods, each microservice becomes highly available. It can scale on its own terms. It can fail on its own terms. Each service can be deployed on its own associated DevOps pipeline. Each can be coded even in a different language, and can be developed on separate timelines. So all of this flexibility at a service level, right? So also container environments, they generally generate more efficiencies compared to the more traditional virtual machines on hypervisors. And this is because containers virtualize the operating system rather than the hardware. And because of this, containers consume lesser resources vis-a-vis VMs. So they are faster, they are more portable. Upgrades and rollbacks and redundancies and even load balancing, they're all software defined, and they are built into the container platform in the new world. Right. So now let me get Amit in. So Amit, what are you seeing with AWS customers? So are you seeing large-scale containerization of new applications? Are customers convinced of the ROI, the return on investment that accrues with modernizing their legacy code bases? And are you seeing any industry-specific or even India-specific patterns? Amit, over to you.
Krishnan, first of all, I would like to thank you for inviting me to this forum. It's great to be here. To answer your question, right? So I would say we are seeing a large-scale movement from monoliths to microservices architectures, and that's across the world, right? And including India. Right? Now, you spoke a little bit about microservices, right? In the AWS view of world, right? The microservice architecture is composed of many small microservices, right? Now, each of these microservices can be either deployed independently, right? And probably each one of them could probably have its own data store. Now, also that as each one of them is independent, each microservice can also be a polyglot in that it can make its own choice of technology, and all of them typically expose RESTful APIs. Now, when we start thinking about microservices, right, I think the first thing that we need to look at is in terms of architecture patterns. By choosing the right pattern, we can shrink the scope of the work and create focus on the applications. The typical architecture patterns that we start thinking about modernizing into microservices would be your typical strangler pattern, package pattern, adapter patterns, which are suited for building microservices architecture. Right? Now, when these typically, as you mentioned, right, when we build these, they are typically hidden behind an API. By providing this hardened contracts, can create a well-defined boundary between the service consumers, the data, and the business logic. Right? It can also become easier to manage and scale our data and services independently. This allows us to create purpose-built solutions without spending less time, try to fit our data into it. Like for example, force fitting. Many times you force fit our data into a relational database while we might just be needing a time series database. Now, if I look at a couple set of customers, right? A couple of customers that come into mind, which have gone this route, is Aon Insurance in Asianet. Aon, as you might be aware, is one of the major international reinsurance, who's well on their journey in terms of building out a hybrid model on cloud. They migrated and modernized 150 plus applications, leading to more than 50% reduction in their time from ideation to delivery. Asianet, as we might, or in India, we are aware, is one of India's largest Malayalam media groups. They have completely moved in terms of modernizing their applications onto a 100% AWS serverless architecture. By doing that, they were able to reduce their operating cost by 50% and their database cost by 48 times. I think the key takeaway is that when we're trying to build microservices architectures, it does lead to real tangible business benefits. So back to you, Krishna.
Thank you, Amit. I mean, great observations, very, very intuitive, especially the fact that you mentioned customers who have changed their operating model and they are accruing mid double-digit savings in their operating costs. This is like you said, right? So the modernizing the applications is really leading to a modern business and new models, new ways to compete and so forth. Yeah, so very, very interesting. Thank you for that. So so this brings us to the next dimension that follows the microservices architecture-based design. You mentioned some architectural patterns while designing microservices and such. So the next step would be, where do we host these container environments, right? So usually by default, the container environments are hosted on a cloud. However, they can also reside on premise if there are reasons not to go to hyperscalers. But if assuming they are on a cloud, the container environment and the containerized application by extension, they can further capitalize on the scalability, the on-demand consumption flexibility, and the software-defined availability, right? That cloud brings is in terms of multi-zone safety, multi-region safety. All of that come with the cloud model. So container on cloud is even more powerful. And the fact is, it's difficult to recreate this or create this on-prem, right? So for example, if you consider a mission-critical India-scale application, whose load swings over time, but let's say it reaches peak concurrent usage levels in the double-digit millions. So if you have to host it on-prem, you will need to plan capacity for the peak load, and this would lead to periods of underutilization and overall cost efficiencies and so forth, right? So if I can take an example, so if you look at a specialized application modernization domain that is increasingly getting more prominence, which is the mainframe mod. So millions of lines of code that has been written in COBOL over decades. They've been running for many years on mainframes. They are now being assessed, they are being rewritten, they are being recompiled into a modern programming language like Java, perhaps. They are being refactored into microservices, deployed to run natively on the cloud. The data is moving to cloud data stores as well, all with the goal of reducing operating costs and getting more value, right? So it is possible today to obtain mainframe grade processing power on any of the hyperscalers. I mean, that too with consumptive billing, right? So the overall operating efficiencies that accrue, including the ones you said, in this case from mainframe modernization, usually makes the investment worthwhile in many cases, but the re-engineering itself can perhaps take months or even years, and there are tools to aid app mod in general, mainframe mod in particular, and so on and so forth. And also an accompanying aspect is the need to leverage cloud native data technologies, right? Such as cloud databases, cloud data lakes, cloud data warehouses, and so on, to host the application data, because this lets you unleash the power of AI, the power of ML, the power of predictive analytics on the data through cloud PaaS services. And in the case where a legacy app is sought to be modernized, the data needs to be modernized as well to get the holistic benefits. So it needs to be moved from a legacy data repositories to cloud data stores, right? So this will help transform businesses by taking advantage of AI-based decision making, right, and aspects such as sales forecasting, perhaps. So let me come back to you, Amit, with this background. So what are your experiential views? You see a lot of customers, you mentioned some customers as well. So how are customers are developing applications? How are they leveraging the power of both cloud native containerization and the muscle of cloud services operating on cloud data stores, right? So what are you seeing here, Amit?
Thanks for that question. So yes, I think you bring in a very interesting point around containerization, right? Especially around the scale of it, right? And cloud, especially public cloud, offers you that this ability to scale. Now, if you look at public cloud, right, AWS currently has a lot more capabilities for containers than any other cloud provider, right? If you look at the vast majority of customers, around 2/3 of them are running containers in the cloud. They're running them on top of AWS. Now, when we look at containers, there are different deployment models. We offer a managed Kubernetes service called as Amazon EKS, as well as our own container service called as Amazon ECS. This gives customer choices. If they want a container service that's deeply integrated with the rest of AWS platform, they can use Amazon ECS, which we fully control. This ensures that if we make any new feature launches in any other place, it's always closely integrated with ECS right from the day of the launch. Now, if the customer prefers to have their own managed Kubernetes service, they can use EKS. Now, just in numbers metrics, 84% of the Kubernetes workloads that run on the cloud today run on top of AWS. But it's not only about just running container services. Right? Customers that they are serving, they prefer to run. Some customers have to worry about servers, clusters. They don't really want to worry about it, right? They just want to run at a microservice level or a task level. Right? In that case, they can use our third serverless offering, which is AWS Fargate. It just makes life seamless in terms of how do you go ahead and takes away all the heavy lifting. Now, when you look at customers' landscape, it's not always just one monocolor, right? Many of the customers prefer just use 2 or 3 of these container offerings to choose the right tool sets for different use cases. Right? Now, when you move to containers, right, there's an aspect of data that you highlighted, right? Now, if you try to force fit containers in the traditional databases, it doesn't always work out because it takes away the independence and the ability and the agility the customers ask, right? So you have to look at what is the managed, right? The purpose-built, there's a lot of different purpose-built databases, right? So in the Amazon world, we have Amazon Aurora, Neptune, DynamoDB, right? Which provide end-to-end services in different models, right? We also have databases like AWS Redshift, as well as EMR services, which actually help you compute that, right? And when a customer starts leveraging these services, the time to market, the agility of the business increases tremendously, because then they can build true cloud native architectures, which can leverage the power of cloud rather than trying to build everything from the get-go. Once the customers have looked at this, right, many customers have moved on to the next stage of the evolution, which is essentially around a serverless strategy. A serverless strategy enables a customer to achieve the maximum value from the cloud. And by serverless, we are talking about applications that are built with technologies that eliminate the need to manage servers, which can scale nearly infinitely and automatically. They use the typical pay-as-you-go pricing model and are automatically highly available, so you don't need to worry about that aspect also. There are customers such as iRobot, which manufactures our Roomba, which became popular during our lockdown, right? That completely runs on a serverless technology stack on top of AWS. Right? And then I would say it not only is about compute, it has been extended to data also. So we have launched many serverless data services over the past years, such as Amazon Redshift and Amazon Aurora. And in these databases, you're not again provisioning servers or managing those. It's pay-as-you-use database services, right? And these are in addition to AWS Lambda, which is a serverless event-driven compute service, right? Now we just talk about another customer. Thomson Reuters, as you all know, is one of the world's most trusted news organization. Thomson achieved nearly 200% productivity increase when they moved from their traditional architecture onto AWS Lambda. Right? I think one of the key messages is that not only AWS provides the deepest and the widest services for customers who are trying to build modern architectures using containers, databases, and serverless, but I believe for us to modernize as customers and as a community, it's very important to start thinking in terms of what is required in terms of cloud native and building cloud first and serverless first applications. Back to you, Krishna.
Yeah, thanks, Amit. I mean, I thought very profound views, especially very interesting the couple of customers that you mentioned, where you said they have almost completely moved to serverless first mode of operations, right? And one of the customers you said achieved 200% savings in efficiencies and such. So, so today, when you have a business model where the load fluctuates wildly, like for example 100 times between a quiet period and a busy period, it's next to impossible to profitably support that business without a cloud native or a serverless first operating model, right? So this cloud nativity is not a nice to have elegant tech option in the new world. It's often an existential choice. This is what you implied, right? So thanks for that. And then you also talked about the agile culture. So let's turn now to the best practices, which is around cloud native DevSecOps, the continuous integration and continuous delivery, which is called CI/CD, and then the agile engineering culture, so to speak, right? So the cloud native narrative, it also implies the adoption of DevSecOps to shift from the traditional practice of a few large releases of a full application to continuous integration and continuous delivery of component microservices, right? So, and these cloud native CI/CD pipelines, they can take advantage of cloud functions to perform iterative builds and rolling updates, such that new releases gradually get deployed, right, across a large user base. And this can limit risk. This can control the radius of any failure that may occur, right? And on cloud, everything is stored and configured as code, be it infrastructure, be it policies, be it observability. And so the deploy portion of the CI/CD pipeline, that can establish this as a code paradigm as well. And finally comes a critical component that goes hand in hand with cloud native development and DevSecOps, which is this agile engineering culture, which is really a value system that rewards development squads for failing fast and improving fast, right? And it encourages what are called blameless postmortems, and motivates the deployment planning that limits the impact reach of any failure. And in a way, it expounds the deliver, fail, change, succeed cycle, where the way to a successful product is to bring out some features, then test the market in a calibrated fashion, and then expand iteratively and then continuously. So this agile engineering operations, if they are combined with cloud native CI/CD or DevSecOps practices, that can lead to a high speed organization, right? And that has a high trust culture as well. So going to Amit. So Amit, what are you seeing in the field, especially with large customers? I'm sure you're seeing many where their cloud run rates run into the millions of dollars, right? How are they building release practices and an engineering culture to exploit the power of cloud nativity and grow their business ultimately?
Thanks, Krishnan. So there are two aspects out here, right? One is in terms of the hard skills and tooling, and the other one is in the soft skills / culture aspect, right?
Yes.
I can, if we talk about DevSecOps, right, I can probably talk about AWS services such as Amazon Code Guru, Amazon DevOps Guru, which were launched recently, right? These services provide insight which you can implement with a few clicks. I can also talk about probably our AWS Cloud ID and others, right, which we use to actually enable all that. I can probably talk about customers such as Coca-Cola and Washington Post, which have drastically reduced their deployment times of multiple access, right? But I think we are all quite aware about those things, right? I think I want to talk a little bit more about the softer side of things, right? About the culture, right? And let me go back a little bit and talk a little bit about something company which is close to me, which is Amazon and Amazon.com, right? So if I go back a little bit in time, right? Back in the year 2001, when Amazon.com was a single monolithic application, which used to run on one single Oracle database. When we wanted to deploy something, we had to take an 11-hour downtime in the system. Right? And now when we're trying to grow into the .com boom and all, this was completely unacceptable, right? So at that time, our CEO, Jeff Bezos, looked into the particular problem and looked at it from a process perspective. To solve this, we decided to increase the amount of ownership of each team, but decrease the scope of responsibility of each team at the same time. we call this concept as a 2-pizza team. The idea was that the team should be small enough that can be fed by 2 large pizzas. And this is typically 5 to 10 people in each team. Now, these teams would not be a one-off team as such. These teams are going to be a long-running team. They have their own set of functionality. Their teams are responsible for developing, testing, and operating a particular service. So we made to an engineering culture, right? Now, then we also made the corresponding technology decisions to support this. Now, if you look at Amazon.com today, right, it has been re-architected completely using microservices. The landing page of Amazon.com is rendered by over 1,000 microservices operating independently. And each one of them, each team is responsible for building their code, managing their code, deploying their code. Now, instead of the 11 hours of downtime that we had earlier, we have 60 million deployments which happen on Amazon.com every year itself, right? So we moved in this culture, we moved completely from a manual model of manual handoffs to an as a service model, in which 2 teams who are working on their own different business need not talk to each other itself, right? Because it's purely as a service model. Now, one thing that we have to remember when we move to this model, it has practical applications in business. Now, application modernization is as much about people management and changing culture as is about technology, right? So I think that is one of the most important things I will leave it is let's not only focus on tech and what our CI/CD pipelines can implement it. It will not lead to results unless we do the corresponding organization changes, which ideally have to be driven from a top-down model so that we can leverage the power of agile, the power of 2-pizza teams, and the rest of the things, right? So back to you, Krishnan, on this.
Thank you. Experiential insights are always captivating, and most of what you said was in client context, right? And even Amazon.com's own story that you narrated, where from hours of downtime, when you redesigned the internal architecture to be microservices based and on the cloud, you are talking about millions of releases each year with next to near zero downtimes, right? So that itself is a powerful story there. So thank you. So let me conclude now. So the art of cloud native programming, this combines a set of related facets, most of which we discussed today. It starts with algorithmic thinking anchored around the microservices architecture, then writing code that is cloud aware and exploits cloud, right? Leveraging cloud data stores, maximizing usage of cloud PaaS services, such as machine learning, such as predictive analytics to solve business problems, then embracing DevSecOps practices, and finally adopting a fast-paced agile culture. Now, success here is if your cloud native application leads to a more digitized business model, leads to reduction in operating costs, faster growth, and overall transformation, right? So with this, we come to the end of this webinar. Thank you, Amit, for the enlightening conversation, and thanks to the audience for the opportunity to speak. Now back to you, Ria.
Thank you so much. First of all, thanks to both of you for that insightful conversation and helping our audience with their questions in mid of your conversation. Once again, thank you so much, dear attendees. We've tried to answer your questions via chat and text. In case you have any more questions, please do reach out to us through any of our online or digital communication channels. We will always be happy to help, always here to answer. Once again, thank you so much. And until next time, please take care and stay safe.